Hey Superstar students, it's Dr. Conklin here to do a lesson with you on modeling inequality. So what do we mean by modeling? Also, we're on page 25, so you can follow along in your notes. Modeling means what we're going to do is we're going to write inequality equations or expressions. Inequality expressions or equations that follow along with a real world situation. So what we're going to do is we're sort of going to look at two ways to do this. We're first going to use a guess and check method, and then we're actually going to write our let statement and use some variables, which I know you guys know how to do. So let's go through and use our strategy for solving word problems. So the first thing we want to do is read through the word problem just once, and we're sort of going to take note of the key parts of it. So for exercise 1, it says a school is taking a field trip with 195 students. So any place I have a number, I'm going to circle it. And 10 adults. Each bus can hold at most 40 students. We need to determine the smallest number of buses needed for each trip. Okay, so let's look at that again. I've highlighted 195. 10 for adults, and at most 40 students. So how are we going to solve this equation? Well, we're first going to use a guess and check method to determine the minimum number of buses needed, which sort of makes sense because in the real world you wouldn't want to pay for extra buses, right? Okay, so we have 195 students. I'm going to pull out the key information. We have 10 adults. Each bus can hold at most 40 students. So actually, the thing we care about is this 195, right? So what we're going to do is we're going to say to ourselves 195 divided by 40. Okay, when we do 195 divided by 40, let me just get my calculator up. Again, we'd really strongly recommend you guys use your graphing calculator. You should not really be using your phone calculator. We get 4.875. So if I do 4.875, we need to think about this. If I have 4 buses, is that going to give me enough room for everyone to be on? So let's just take a second. If I do 4 times 40, that's 160. Is that enough to fit all the students? And remember, we have some adults too. It's not going to be. So this is one of those times we have to round up. Ooh, 2 S's for buses, I guess. 5 times 40 is 200. Which would give us more than enough room for our students, okay? So now let's write a variable. N is the number of buses taken on the field trip. So 40 times N. We want to write an inequality. So what does that mean at most? So if we think about well, before we do, let's actually write here, right? We did 40 times 4 and 40 times 5, and we wanted that to be no more than 195 students, because say we had tried even like 40 times 6, right? That would be 240 students. That'd be too many, right? So we want to have something that is greater than or equal to 195, okay? So if I take and divide by 40, we're going to get N is greater than or equal to the same thing we did, 4.875. Oh, guys, actually, I'm sorry. When we have at most, I'm just checking my notes here. At most, where do we have at most? Let N be the number of buses taken on the trip. Write and solve an inequality that models this problem based on N. So we want the minimum number of buses. So when you hear minimum, less than or equal to. So our inequality here should be less than or equal to. But if we think about this, we can't have a number that is 4 because it doesn't fit everyone. It would need to be 5 like we worked out before. Okay? We also have some questions like example 2. It says, translate each of the following into an inequality. We don't want to solve, okay? So if I read through this first, 3 times, let me choose a different color. 3 times the number N is increased by 12. the result is at least 32. So here's my number, increased by 12, at least 32. So 3 times n, increased by means to add, at least 32. So if you think about at least, if I have at least $32, does that mean I have more than 32 or less than 32? So at least means I probably have 32 or above. So we want to make sure that the result is at least greater than or equal to 32. Okay? Questions so far on those? Let me go to the next page. Actually, I don't think we want to do page 26. I think we just wanted to do one more down here. Okay, so let's do example 4 and then we'll call it a day. Find all the numbers such that twice the sum of the number and 8 is at most 4. So sum is adding. Now, we don't have a variable, so we have to start off by saying let x equal a number. Remember, you could use any number you want, right, guys? So we have 2 twice the sum of a number and 8. So there's almost like magical parentheses here. Is at most 4. So what does at most 4 mean? So if I think about above 4 and below, if I have at most 4, it means I've got 4 or less than. So less than or equal to 4. Now we actually do need to solve this, okay? So I'm going to distribute my 2. 2x plus 16 is less than or equal to 4. Let's take away 16 from both sides. So 2x is less than or equal to negative 12. Divide both sides by 2. X is less than or equal to negative 6. Okay, so that's page 25. There's nothing to hand in for an assignment today, just this work. But please let us know if you have questions, and we're happy to help. Have a super day. Bye, guys.